Ajay ji, are we ready?
Just yeah, minute.
Yeah, before you start sharing your screen, we will give the introduction. Okay,
Sure.
to the speaker, to all the audience, all the participants. So I request Professor Ganesh to give introduction of our today's speaker.
Yeah, good evening, everyone. It is my pleasure to introduce our distinguished guest speaker, Dr. Ajay Kumar, an accomplished researcher and academic in mechanical engineering. Dr. Kumar completed his bachelor's degree from MITS Gwalior, following by an MTech in materials engineering from Maulana Azad National Institute of Technology, Bhopal. He then earned his PhD from IIC Bangalore in 2016. His research journey took him to the United States, where he pursued postdoctoral studies at Washington State University and the University of Wisconsin. Since December 2019, he has been an assistant professor at IIT Tirupati, contributing significantly to areas like advanced metal casting, metal forming, materials processing, tribology, and surface engineering. He has an impressive record of 32 international journal publications, 5 book chapters, 4 Indian patents, among them 2 are granted, and numerous conference presentations. Recently, his contributions were recognized with the Chandran Menon Memorial Award for Applied Research and Innovative Technology, which he received at the 72nd Indian Foundry Congress in February 2024. With such an impressive background, we are privileged to have him with us today. On behalf of everyone, here I warmly welcome Dr. Ajay Kumar. Sir, we look forward to your session. The platform is now yours.
Yeah, thank you so much for the kind introduction. So, so I have two talks now continuously, one after the another. Okay. So, Dr. Vinayak, can I know how many participants and are there? How many students? How many faculty? Just to so that no, I will accordingly
Yeah,
deliver the talk.
so total of 181 participants have registered.
Okay.
So large pool is from faculty. So
Okay.
a few are research scholars,
Hmm.
and few of them are from industry side.
Okay. Okay.
So the population is
Total 181 are there, right? Total 181.
181. Few are yet to join. Slowly they will join.
No problem. No problem. Just give me a moment.
Yeah.
I'm just opening the presentation.
Ajay ji, you have to share your screen. Huh?
Yes. I'm sharing. Just give me a minute. Yeah, sorry for the delay because I was a little late in coming from my institute.
Yeah. No issues.
Yes. Okay, now my screen is visible now. Can you hear me? Anyone can give yes or no?
Yeah, Ajay, it's visible.
Okay.
Uh, it's in the presentation mode, right?
Yeah, it's in the presentation mode,
Yeah. Yes. Yes. And I
right?
think yeah, we are good to go. We can
Okay.
start.
So thank you so much. Um, Good evening, one and all. So today I am going to share my ideas and knowledge with you on one of the topic which is given on the energy storage and conversion materials. And so I will be spending some time on explaining the uh, about the different type of energy storage systems and energy storage materials, why it is required, right? And then we will also have a open interaction. I will be explaining some of these applications as well, and then we will have open interaction so that no you can ask any questions, and then accordingly we will discuss. Okay. So the outline of the talk is I will give a brief introduction, and then I will discuss about the energy storage systems, and then uh, ways for enhancements in energy conversion efficiency. So to keep you in the brief thing that now energy conversion system, or say energy storage and conversion system. So all of you are aware that the importance of energy generation is there, because if you see any country like India, um, we are the, you can say, the largest population country if you compare, and the demand of the energy generation and implement is also increasing day by day. So we have two reasons to understand the importance of this energy generation. One reason is the population growth of any country, and the urbanization which is happening every day. So people are migrating from a small place to the cities, and then you can see the population migration. So when people come from one place to another place, they have to meet the certain requirement in terms of energy, in terms of their needs. So that is why this energy uh, requirement, the fulfillment of the needs of the people, that is why this is important. Now second thing is this energy requirement, we are having various resources to get these energies. uh, we are harnessing the natural processes through solar, wind, and we also have the renewable energy, which offers the continuous replenishment for the fossil fuels. So most of you will be aware that uh, we are using different type of energy systems today, and those those systems are based on the fossil fuels. So you can take the example of the coal mines, and those coal mines, we mine the coals, and then that is used for the various power plants, and then from that power plants it goes for the energy generation, and that energy generation we use in the form of the electricity or other forms. So we have different form of energies: chemical energy, electrical energy, elastic energy, gravitational energy. So these are all potential, they all come in the potential energy domain, right? And then also another domain of this energy is the kinetic energy. So we have two domains: one is the potential energy, another is the kinetic energy. So and then in that kinetic energy we have several categories. For example, mechanical energy, electrical energy, thermal energy, sound energy, and radiant energy. So what is happening is uh, we are having the natural resources or natural processes for the energy, and at the same time the energy access also becoming limited. Why energy access becoming limited to everyone? Because the population growth and urbanization. That is why we need to have a system. We need to have a energy storage system where we can store the energy and then convert the energy into different forms. Okay. So the energy sector is transitioning from the towards the cleaner, towards the decentralized system to address the climate change, energy security, and then it is also driving the uh, innovation for the sustainable future. Okay, so what you need to understand is the the predominant concern today in daily life, which revolves the around the energy production and optimization in its utilization. So that is why energy storage systems have emerged. Okay, now what you need to understand is the energy utilization um, underpins the functioning of the world, with energy being the capacity of a system to accomplish the work, right? So that is why the energy storage system is going to play the important role, how we can store the energy in an efficient manner and then utilize for accomplishing any work. Okay, so now most of you will be aware about the law of conservation of energy. Okay, so law of conservation of energy, which says that the total energy content of the universe remains unchanged, right? So that is the law of conservation of energy. And then you also aware that this energy is immutable. It can go under conversion from and or transfer from in the various forms, right? um, but it cannot be created nor destroyed, right? So this is the fundamental law of conservation of energy. This energy is immutable, like it goes for the conversion and transfer between various forms, but it cannot be created or destroyed, right? So this is the law of conservation of energy. Now the energy transformation also hinge on the concepts of classical mechanics, particularly to the movement and evolution. And most of you are aware that energy is measured in the scientific units, which is known as the joule. Okay, so joule uh, is the unit for the energy, right? And the potential energy and the kinetic energy. So I have mentioned the two categories, uh, potential energy and kinetic energy. So we have to play between these, and then these energies can be converted into various forms. Okay, so this is how the concept of the energy, what is the importance, why it is required, and then the law of conservation of energy. Okay, so this picture shows you the diverse spectrum of the various energy forms. So we have the chemical, electrical, elastic, gravitational energy, and then we also have the kinetic energy in the form of mechanical energy, and then we have the electrical energy, thermal energy, sound energy, and radiant energy. Now let us discuss about the different type of energy flow system. So when you have the energy has to transfer from one form to another form. So basically it should have the energy flow system. So what is the energy flow system? So energy flow system says the energy transforms in the different form, and later on it is stored in the different usages. So we have different type of energy flow system. For example, I will give you some examples. For example, we have the uh, wind turbine, we have the photovoltaics, we have the different type of utility grids, energy grids, and then we also have the different type of heating and cooling systems. And then we also have the uses for this. So if you see, energy from the wind turbine, energy from the photovoltaics, energy from the heat and power, energy from the electric grid, right? And energy from the different type of heating cooling systems, it is basically stored in one place. So that unit is known as the, is called as the energy management system. So you have to manage the energy flow through the energy management system. Now, once you have the stored this energy in the energy management system, then you have to put into different uses, right? So we have that energy comes to our house in different forms, comes to our the automobile in different form, right? So we have the energy source, that is renewable energy or non-renewable energy, and then we have the energy conversion mechanisms, and their energy conversion mechanisms are different. So those energy conversion mechanisms can be based on the photothermal concept, can be based on the thermoionic concept, can be based on the thermoelectric concept, and you also must be aware about the ocean uh, ocean energy, bioenergy, and then here I am giving the example of the chemical energy, and also from the fuel cells, from the electric motors, from the turbine, right? So those comes under the mechanical energy or thermal energy or electrical energy, right? So now, once you have the energy, then you have the energy source, and then you have the different mechanism for the energy conversion. And now you also need to distribute the energy. Okay. So you distribute the energy in different forms, in different ways. For example, one example for distributing the energy is the heat transfer. So most of you will be from the mechanical background, so you must be aware about the heat transfer. So the heat transfer, through heat transfer, the energy will be distributed in different places. Second example of energy distribution is the power transmission. Okay, so through the power transmission, that comes under the electrical energy. So through power transmission, we distribute the electrical energy, and then also we have the smart grids. Okay, so the electrical grids you must have seen in various cities now, smart cities. They are coming up with the smart grid system, right? So to distribute the energy in an efficient way and evenly distribution. Now, after the energy conversion, then you have the energy distribution. Then comes to the energy storage. Now, how will you store the energy? So energy you can store in a different form. Okay, so one form of storing energy is the thermal storage. Then we have the chemical and mechanical storage, and then we have the electrical energy storage system. Okay, so these are the different energy storage system which you may need to remember or aware. One is the thermal storage, chemical storage, mechanical storage, the electrical energy storage system. Now, once you store the energy, then you have to use the energy, right? So this energy, how will you use? Like every day in day-to-day life, you are using this energy in various forms. So suppose in transportation, you are using this energy. In air conditioning, you are using the energy. For the different type of thermal utilities for industrial and commercial purpose also, you are using the energy. So these examples you also can understand from the from your organization or institution. Okay, so this is how the entire system and flow of energy it goes. So I started with giving you the fundamental definition and then discussing about the law of conservation of energy that you must have studied in your intermediate, and then we have discussed about the different type of energy sources. So energy sources, and then energy conversion, and then energy distribution, then comes to energy storage, and then comes to energy uses. So now let us discuss about the what you call energy sources in detail. We'll spare a little bit time on it. So when it comes to energy sources, what do you understand? What do you mean by the energy sources? So energy sources means, uh, as I gave the example of the energy sources, you have the two type of energy sources. One is the renewable and non-renewable energy sources. So basically, they are encompassing a diverse array of options where you have the range of renewable energy sources, and then you have the range of non-renewable energy sources. So, and when it comes to the renewable energy of sources, the example of the renewable energy of sources are like you have solar energy, you have the wind energy, you have the hydroelectric energy. So basically, these renewable energy sources, they are naturally replenishing process sources. Okay, so basically, these sources are available to you naturally, right? For example, solar. For example, wind. Right? For example, hydroelectric. So basically, what are you doing is in the solar energy system, you are harvesting from the sunlight. So when you want to harvest the energy from the sunlight, how will you do? Generally, you use photovoltaic panels. Generally, you use the solar thermal systems, right? We also have the solar battery systems. Okay, so through the photovoltaic panels, through the solar thermal systems, you are converting the solar energy into different forms which you are using in our day-to-day applications. Now, when it comes to the wind energy, you know that it is basically we use the different type of windmills, and those windmills are installed in a area where the speed of wind and the availability of the wind is uniform, and most of the time it is available. So in those locations we install the windmills, and then they also inbuilt with the turbine in the windmill, and then that wind turbine convert the kinetic energy into the electricity. So through the windmill, we get the uh, electricity. So basically, it is the conversion of kinetic energy into the electrical energy. So this is another source of the renewable energy. Next source of renewable energy is known as the hydroelectric energy. Basically, hydroelectric energy is harnessing the gravitational force of flowing or falling water. So you must have seen in various dams that those dams are made on the different rivers, right? So we are basically utilizing the gravitational force of the flowing and the falling water, right? And then we convert that energy into the electrical energy. So that is a third system, a third source, where we have the um hydroelectric energy from the water. So you have the energy from the sunlight, energy from the wind, energy from the um, uh, hydropower, and then another renewable energy of source is the biomass energy. So biomass energy means the basically you will be knowing the meaning of the biomass. Biomass basically refers to the organic materials. So organic materials such as you will be knowing about the wood material, you will be knowing about the agriculture residues, and also you will be knowing about the organic based. um and then what we do in the biomass system, we basically do the combustion process, then fermentation process, and then after that gas process. So you will be knowing that in various villages they have the biomass system, where that biomass system they use for various household applications. Even for cooking also, they have that application. And then the last renewable energy source is the, what you call is the geothermal energy. So geothermal energy, it is basically uh, energy system where you utilize the earth's heat beneath the surface, uh, and in the beneath the surface means the heat which is there beneath the surface of the earth, it will be used for the in the hot water or maybe in the steam reservoirs, and through that they generate the electricity. So these are the different renewable energy sources which you use for the different energy systems and energy flow systems, and different later on different uses, right? But you will be also aware that the efficiency of these energy systems is not that great, right? So now the lot of research work is going on. For example, how we can increase the efficiency of the solar panels or photovoltaic panels, okay? And how we can how we can address that the solar panel system to our regular electric system. So a lot of research is going on to increase the efficiency of the solar panels, okay? So there is a international solar alliance, we say ISA. Most of you will be aware, I don't know. So there is a international solar alliance, ISA system, where the that alliance is working on to make these solar power plants, okay, in different cities. For example, in India, uh, a few states are now uh, developing the concentrated solar power plants. So where several solar panels will be installed at one place, and the sunlight will focus on those solar panels, and then that solar the sunlight will be converted into the electrical energy by a proper channel. So the installation of those concentrated solar power plants in different states, now that international solar alliances is taking the initiative in different countries. So India is one of the leading country where they are working on it. Now next uh, topic is to understand is the non renewable energy sources. So non renewable energy sources are many, right? You will be knowing about the coal, you will be knowing about the petroleum, you will be knowing about the natural gases, right? But you also know that these non renewable energy of sources, we are mining so much because of our need, right? The everyone has to make their need. The population is increasing day by day, so to meet the requirement, we are mining from the coal mines. We are also harnessing the petroleum products, natural gas from, but these resources are limited. So when these resources are limited, we are looking for the alternative energy resources. Now when we talk about the alternative energy sources, right, we are also talking about the energy storage system, energy conversion system, right? So because, for example, why we need to have the energy storage, energy conversion system? Because, for example, take the example of the solar system, solar energy. um, in some of the places the sunlight will not be there for all the time, okay? In some of the places sunlight will be there, okay, all the time. So that is why we need a system, a storage system, where whenever there is a availability of the solar light, so then we can store that solar light, right? And then wherever is required, and then we can convert that solar light into the energy, and then later on it we can put into different uses, right? That is why we need a system for energy conversion or energy transformation, okay? So then we talk about the energy transformation. So what do you mean by energy transformation? Energy transformation is very simple to understand. So energy transformation is an energy flow system, okay, which has the raw energy from the various sources, and then it goes into the usual form of different energy applications, okay, and then in between we use different systems, okay, so that no, this entire process will be efficient. So the energy transformation, you need to have a raw energy from the various sources. Either it can be the renewable energy source or maybe non-renewable energy source, and then you convert into the usual form of energy, okay, that you have now understood. So we have the different commercial energy conversion systems you will be knowing for the end use applications. So one example I will explain here. One example is the electrical to mechanical energy conversion. Okay, so how do you do the electrical energy conversion to mechanical energy? So if you take the example of the power plants, okay, in power plants the electrical energy generated from sources, you will be knowing the coal we use there, we use the natural gas, sometimes we use the nuclear or renewable sources also, which is converted into the mechanical energy. So what we use is we generally use a lot of generators, okay, and where the electric current also include the magnetic fields, and that cause the rotation of the motor and mechanical work to be produced, and through that we generate the energy. So you have the electrical to mechanical, and the same thing mechanical to kinetic energy conversion, okay. So when you have the energy which is converted into the mechanical energy, the rotating motion of the turbine, or the what you call the different type of machinery, uh, you also need to have the transmission lines, and those transmission lines will help you to converting the mechanical energy into the kinetic energy. So you have the conversion mechanism where you have kinetic to mechanical, mechanical to kinetic energy. Now I will give you some examples just to make you understand energy transformation in the human life, okay, how in day-to-day life how we can understand this energy transformation, okay. So for example, you take the energy source as a solar energy, right? So what is the energy transformation mechanism in solar energy? Anyone? So solar energy resources, if you take as a solar energy, the energy transformation mechanism, you are aware that there is a chemical energy, okay. So the application of this is the photosynthesis in plants, right? So photosynthesis, you are well aware of the process. And then another energy source, for example, you take the energy source of chemical energy, right? So energy source chemical energy, and what is the energy transformation? The energy transformation can be kinetic energy, okay, and that application of that kinetic energy you are using in the muscle movement. So I am giving the example in our human life, okay, that how these energy sources and energy transformation and what is the exact application. So one application of solar energy is the chemical energy where photosynthesis in plants, okay, because plants also having the life. And then another example is the chemical energy where you are having the energy transformation, the kinetic energy, and then from there you are doing the muscle movement, right? And then similarly, this chemical energy, if you are having the resources, you can also have the energy transformation of electrical energy, and this electric energy you are using in the application of the battery discharge or fuel cell, okay. Another example I will give you, let us say thermal energy, okay. So thermal energy, if you take, then this, if you use the energy transformation as a mechanical energy, right, this can be used in the diesel engine, okay. So this is how you need to understand the transformation of energy from one form to another form, and what is the application of these things. Okay. Now, so you have understood the mechanical to kinetic conversion. Now, next is the kinetic to electrical conversion. Okay. So how will you understand the kinetic to electrical conversion energy? So when it comes to kinetic to electrical conversion energy system, what you have to do is the electricity travels through the transmission lines. You must have seen the transmission lines. The electricity will travel through the transmission lines, and then what will happen is the kinetic energy it will be converted back into the electrical energy at the substations or the transformers. That is how you get the power in your house. Okay. So but this conversion is necessary for the efficient transmission, because during the transmission there will be several losses, so you need to avoid those losses. Okay. And those losses, if it is for long distance, the losses will be more. So a lot of work is going on how to minimize the losses during the transmission. Okay. Now next conversion of energy is the electrical to thermal energy conversion. So what do you mean by electrical to thermal energy conversion? So what happens is, in this case, the end use devices, if you take, let us say, electrical heater, okay, or electrical any appliances, if you take, for example, electrical energy is converting into the thermal energy. Okay. Through the, basically you have the resistive heating element there. Okay. And then you are using this in your house as well. For example, you are using this for heating, you are using this for cooking. Okay. So this is how you use the, what you call, another energy conversion. Now let us understand the another energy conversion mechanism, which is, there are various conversion. I can give you the example. For example, electrical to electromagnetic conversion of system. So what happens in this electromagnetic energy conversion? You must have seen this type of conversion in the transformers, where electrical energy is converted into the magnetic fields. Okay. And then what happens when you convert the electrical energy into the magnetic fields? These magnetic field induces the current in the nearby conductors, and then what happens, the and that magnetic field and then the current into the nearby conductors, and that will basically facilitate the transmission and transformation of the electrical energy. So that happens into the these transformers, and that transformers you have seen. Now next, an important energy conversion which you will be interested to understand, the electrochemical energy conversion. So the electrochemical energy conversion, basically I will give you the example of electrochemical energy conversion, so that now you will understand better. You take the example of batteries or maybe fuel cells. Okay. Where the electrical energy is converted into chemical energy first, and during the charging, or there is a process known as the electrolysis process. So electrical energy uh, uh, uh,
JJ.
converted into the chemical energy, and then what happens is, the during the electrolysis process, and this chemical energy again can be stored into the battery, right, and then it can be used for the further applications. So this is how, this is what happens in case.
Ajay,
Yeah.
Ajay,
What
sorry.
happened?
Just one query. Is the slide only on the slide number 5, or the slides are changing? Because we are seeing as slide number 5.
Okay, 1 minute, let me see. So you can't see the slide changes.
Yeah. It was there at slide number 5 from a long time. So where it was talking about
Okay.
kinetic. potential.
Okay. Let me just see what is the problem. Now it is visible. Wait a minute, let me see.
Yeah.
Now it is visible.
Yes.
Okay.
Yeah.
Okay. 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 So how much I have, Dr. Binayak ji, now?
Yeah. You can just
Okay. Okay.
recollect.
I will continue it.
Yeah.
Hmm?
You can recollect because it was stuck at only one slide, so we
Ah.
were a little confused. Like
No problem. No problem. So basically, I am trying to explain the energy conversion mechanisms.
yeah.
Okay, and then I am taking some of the examples. So actually, this is the slide where I was talking. Okay,
Yeah.
so yeah, any question if anybody is having, then they can ask. Then I
Yeah.
can I
Yeah,
can
can you change the slides again, back and forth, yes, so that we can?
yeah.
Yeah, front again. Go ahead.
Yeah. So I have other slides to show
Yeah.
here, so
Because
you can
yeah,
see. So
content.
I was actually covering this part, and explaining things.
Ah,
So now, if any participant is having any doubt in understanding any things, then we can. Then I'm going to discuss the energy distribution system. So now I discuss the conversion mechanisms. Okay. So shall I continue or shall I?
yeah, we can continue. We can.
Okay. So I was discussing about the what do you call? 1 minute. I will just. Dr. Binayak, can I take just 5 minute break? Yes, I will just drink some water. Okay.
Yes. Please,
I
yes.
will just take some 5 minute break. I will come back.
Yeah.
Hello.
Yeah, Ajay. Yeah.
Hello.
Yes, I did. Yes,
Okay.
everyone is. Yeah.
So I'll just go through it. So any doubt? Any question till now? I have discussed the different type of energy sources, conversion mechanisms. Any doubt till now, or we'll continue it?
We'll continue. Ajay.
Yeah, because it is the topic. The title of the talk is energy conversion and this storage. It is what you call is the very vast topic. And so what I am discussing at the very starting beginning, and then I will also now I will discuss some of the mechanisms, and then I will also discuss the what are different type of energy storage materials, okay, for the different applications. Okay. Okay. So now, in brief, you have understood the concept of energy, the conservation law of energy, and then different type of categories of energy sources. Then you have understood the energy flow system. You have understood the different type of mechanisms, and then I have given you um, a few examples of the solar, water, and then I have also the conversion of electrical, mechanical, and kinetic energy, right? And then the most important today, people are discussing about the battery storage, right? The electrochemical energy conversion. So there, basically, the electrochemical energy conversion takes place. Okay, and then next conversion, which is known as the thermal to mechanical energy conversion, which is you must have seen in the steam turbines or in the thermal power plants, where they have the thermal energy, thermal to mechanical energy conversion. Okay, so now I will give you some examples of the quickly energy distribution. So energy distribution, uh, the meaning of the energy distribution for the different energy forms, basically it is the process of delivering the energy from source to the end user. Okay, so or the consumer, end user can be anyone, end user or maybe consumer or customer, right? That is the definition of the energy distribution. So how this distribution takes place? The distribution takes place through the different type of transmission lines. So you must have seen the high voltage transmission lines. Then you must have seen the different type of grid structures. So those grid structures are used for the energy conversion systems, energy transmission systems. Okay, and then you also have the distribution system for the, you have the solar photovoltaic panels, you have the wind turbines, you have the fuel cells. So basically fuel cells, they utilize the electrochemical energy reactions, and then they burn the natural gases to produce the electricity. And and nowadays you must be knowing that in this fuel cell technology is also is developing. Okay, so basically in the fuel cell they utilize the electrochemical reactions and then burn the natural gases to produce the electricity. Uh, Basically, it is a clean and efficient. That is why people are using the fuel cell technology. Okay, now let us discuss about the storage system. So, what do you mean by the storage system? Energy storage system. They have evolved significantly from several decades, and they are playing the very important role in managing the energy resources. Okay, so energy storage, you have to store the energy in different form. So the primary motivation or motive of energy storage is to convert the energy from less convenient or economically storable forms into the more manageable forms. You can say in a layman language, you can understand the from the less convenient or economical storable forms into the more manageable forms. That is the layman definition for understanding the energy storage. And if you go for the proper classification of the energy storage, then we have the mechanical storage, we have the chemical storage, we have the electrochemical storage, we have the electromagnetic energy storage system, then and then we have the thermal energy storage system. Okay, so without going into further details, I will just briefly telling you about these mechanical storage. By examples I will give you so you will understand better. So mechanical energy storage, you have the flywheel, you have the hydro storage devices, you have the compressed air energy storage systems. Okay, when it comes to the chemical energy storage, you have the different battery technology today. So people are talking about lithium ion battery today. Okay, and then when it comes to the electrochemical energy storage, that also example is batteries, includes the lithium ion batteries. And then we have the electrostatic or electromagnetic energy storage system. So you will be aware about the capacitors or supercapacitors, where we store the energy in the electric field. Okay, or the electromagnetic field. So these are the different examples of the energy storage systems. And then for example, thermal energy storage system, you have the generally in the thermal energy storage system. For example, you take the example of the solar panels. Okay, so I gave you example of the solar power plants. For example, concentrated solar power plants, which many states now installing. So to store the thermal energy, they use the molten salt or the phase change materials. You will be aware about the phase change materials, PCM in short we say. So molten salts they use, PCM they use, and basically what they do is uh, these molten salt they become liquid at the high temperature, and then they absorb the and retain the heat, okay, when heated, and release when it cooled. So that is the concept of using the molten salts and the phase change material also. And these molten salts are especially used in the solar power plants to generate the electricity. Okay, so
Ajay
these
ji,
are different
Ajay,
examples I am
Ajay,
giving. Yeah.
yeah, yeah. We are seeing slide number 5. Have you gone ahead?
I'm not seeing. I'm still in this side. I'm just explaining the mechanisms and system. I'm still in the same slide. Yeah.
Yes, yes.
Yeah. When I will change slide, it will be visible.
Okay, okay.
Yeah. So most of the things I'm explaining through the examples. Okay. So now I would like to go to the energy storage materials, or you can say the energy materials, and I will explain different type of energy storage materials. Okay, so energy materials, when we say energy, I don't have any slide for the energy materials, so I'm giving you the explanation. So energy materials, when we say, I will give you the different type of categories of energy materials. So energy materials, basically to understand the energy material, you need to understand the definition, or simple in a layman language, you can say the energy conversion or the storage device operations. They play a very important role. And you must be knowing the battery storage materials. You will be knowing about the thermal storage materials, and then you will be knowing the supercapacitors storage materials. So these three categories I will explain you in detail. Okay, so let us first start with the energy storage materials for the battery. Okay, because most of you will be interested in the battery materials. So nowadays you will be knowing about the lithium ion batteries. Okay, lithium ion batteries, now India is developing the technologies, but due to the lack of materials availability or resources in India, we are importing many of these materials. Okay, so these materials become important to for the storage materials. Now, lithium ion batteries, you will be knowing that these batteries are used for the portable, in the portable electronics, and the also in the electric vehicles. Okay, and why we use these materials? Can anyone answer why we use lithium ion battery or lithium in the electric vehicles or maybe the portable electronics? Any answer? Most of you will be aware lithium ion batteries. Most of you will be hearing about lithium ion battery and electric vehicles also. Anyone can answer? So the answer is very simple. You need to understand the why we use the lithium ion battery uh, uh, in the electronics, also in the electric vehicles, because two things you need to understand. One is the high energy density and the long life cycle. So because of these two things, they are using the lithium ion batteries. Now other materials are also coming up. Okay, but the important scientific uh, motivation to understand why we are using the lithium ion batteries, because of they are having the high energy density, as well as they are having the long cycle life. Okay, so that is why lithium ion batteries are being used. And in this battery storage materials, another category is known as the solid state batteries. Okay, how many of you heard about these solid state batteries? We say SSB, right? So solid state battery, basically it represents the future of the energy storage material, and it is going to play a crucial role in the battery technology. Okay, now people are working on the solid state battery technology. So what they will do is they will replace the liquid or the gel electrolytes with the solid alternatives. Okay, and so what will happen is once we replace this material with the solid alternatives, the the benefit of this is you will further increase the or further improve the high energy density, and also you will enhance the life cycle of the material. That is why now the current trend is people are shifting from lithium ion battery to the solid state batteries, where they will be replacing the liquid electrolyte into the solid state materials. Okay, so you will be knowing, I will give you some example, like we have the uh, material, for example, solid electrolytes. We have the lithium metal anodes we use. Okay, and then some of the advanced cathode materials are also being used as the solid alternative materials in the solid state batteries. Now another category of battery storage material is the lithium sulfur batteries. Okay, so lithium sulfur batteries, they also have the um, benefit of increasing the high energy density. Okay, and but they also have some challenges when we talk about the sulfur, lithium sulfur, right? So for example, challenges in lithium sulfur batteries are like uh, they have the polysulfide dissolution and low sulfur conductivity, and because of these two things, researchers are working in this direction, that if they can develop these lithium sulfur batteries for the crucial applications. Okay, now another category of this battery material is the metal air batteries. Okay, so metal air batteries, again, the motivation is same. They want to increase the uh, energy density, and also they also have the reaction properties of metals and the oxygen from the air, and which basically have the exceptional energy densities. So basically, to use all these materials, the the main scientific motivation is to increase the energy density and the life cycle of the material. That is why you are now having lithium ion batteries, then you have the solid state batteries, then you have the lithium sulfur batteries, and then metal air batteries. So this is how people are working. But lithium ion batteries now in the more established form, lot of couple of lithium ion battery plants are being installed in India. And now but people are still not there where these solid state batteries and other batteries materials can be used with a confidence. Okay, so these comes under the what you call uh, battery materials. Now, what are the different key materials are being used? So you will be knowing the key materials. One is the lithium cobalt oxide, another is lithium iron phosphate, another is the lithium nickel manganese. And so these are the key materials are being used in these solid in these battery storage materials. Now, next is the super capacitor storage materials. Okay, so super capacitor storage materials are basically what is the importance of this? The super capacitor storage materials, what they do is they store the energy through the electrostatic attraction of opposite charges. That is how it happens, and it happens on the electrodes. And then what they do is they enable the rapid charge and discharge cycles. So that is the concept the super capacitor storage materials do. They store the energy through the electrostatic attraction of opposite charges on the electrodes and then enable the rapid charge and then discharge cycle. These three things happen in supercapacitor storage materials. Now, next is the hydrogen storage materials. Okay, so hydrogen storage materials uh, are very important. You will be knowing now the India is has launched the hydrogen mission. Okay, and that hydrogen transportation, now they are having the plan of hydrogen transportation through the natural gas pipeline, right? And then what you do is without any damage in the existing pipeline. So they will be mixing the hydrogen with the natural gases, and then what you do is uh, they transport the hydrogen from one place to another place, right? And then they use for the different type of energy storages. But one problem with the hydrogen storage material is you will be knowing about the hydrogen embrittlement. Okay, hydrogen embrittlement, yeah, how many of you are aware about the hydrogen embrittlement? When it comes to the hydrogen storage materials, the hydrogen embrittlement, one has to understand. So hydrogen is the smallest atom. Okay, so when it comes in the contact with the any other material, right, it goes and sits near to the atomic sites in the material, and then it creates type of a defect, okay, in the localized, for example, on the grain boundaries. Okay, a lot of defects it generates. Okay, and then it creates the defect is known as the hydrogen embrittlement. Okay, and that hydrogen embrittlement, once it starts inside the material, okay, then what happens is the crack will start from that location, and finally you will have the failure of your component because of the hydrogen embrittlement problem in your material. Okay, so there are a lot of work is going on to avoid this hydrogen embrittlement problem in the hydrogen storage energy systems. So you have to carefully select the material for the hydrogen storage system as well as hydrogen transportation system. Now I will give you an example. In the hydrogen transportation system, the plan is to mix the hydrogen with the natural gas, and the mixing should be around 10 to 20% mixing which you can do, and then you pass through the existing pipeline which we are using. So in the pipeline we use the different type of steel grade materials. So different type of steel grade materials we use, and some of these steel grade materials are very prone to hydrogen embrittlement problems. Okay, they easily catch the hydrogen, and then they're very prone to embrittlements. Okay, so now the research is going on to develop such materials for these hydrogen storage devices, hydrogen transporting devices in the pipeline or any other storage devices, where the you have to develop the new material which should be resisting the hydrogen embrittlement problem. Okay, so there I will explain you with one example. So when you have these pipelines, these are made up of the different type of steel grades, and then uh, they are also using different type of coatings on these pipelines. So you must be knowing different type of polymer coatings, different type of ceramic coatings, different type of other metallic coatings also they are using. Okay, well established coatings are there, but these coatings uh, are not for entire life cycle of that component. After some time it degrades, right? So once it degrades, then what happens is the same material, if you use for the hydrogen transportation, the hydrogen will directly come in the contact with the pipeline material, right? So now we have to come up with a mechanism, whether can we develop a coating or can we develop a material where we can use in the existing pipeline, because the pipeline which is now being used for hydrogen storage or hydrogen transportation, right, we cannot replace entire pipeline. So we have to come up with a material coating or a advanced material which can avoid this problem. Okay, so I'll give you an example where our team is developing some of these materials where these we are developing some of type of coatings, you can say claddings. Coating or claddings are same depending on the thickness of the material. So what we have developed is we have developed the reverse cladding or reverse coating technique. So if you take the example of the conventional coating technique or conventional cladding technique, you have the material which has to be, you have a substrate material, then you have the material which has to be coated or cladded, right? So this is the conventional way of coating. If you reverse this process, it will be known as the reverse cladding. So we have come up with that reverse cladding or reverse coating technique, and then we have demonstrated that these claddings can be done on these steel pipeline materials. Okay, and then that can be used uh, to avoid the hydrogen embrittlement problems. Now in these pipelines, when we are using the entire pipeline as the steel material, it is also having a lot of weight, and also when you install these pipelines, it requires a lot of manual power, a lot of other things to install. So can we do the light weighting of this material, as well as the same time can we come up with a mechanism to avoid the hydrogen embrittlement problems? Okay, so we have developed these things, and what I mean to say is you must have seen the what we call these optical micrographs in your manufacturing or material science courses. So I'm just giving you some example how to understand. When you have the hydrogen, the hydrogen will sit on the uh, grain boundaries, okay, inside the atom, and then it will create a defect, which is defect is known as the hydrogen embrittlement. And once you have that defect, right, and when that component is under operation, that defect will slowly open up, right? So initiating the defect, then it is basically the propagation of the crack. It goes very fast. So you have to come up with a system where this hydrogen embrittlement problem in the hydrogen storage devices can be minimized. So we have developed these technologies, and then some of these cladding methods for the hydrogen. So the existing methods are there. You must be knowing different type of cladding process. In even some type of welding process are also used in the what you call developing the coatings. Okay, but in the welding process, you must be knowing the when we are doing the welding, we are having the heat source, we are having the material which is localized in the molten phase, right? And then after that it is going to be solidified. For example, you have the nozzle, you have the heat source, then you have the melt pool, and after that you are having the another material which is going to be cladded, right, over the base material. So but what is happening is when you are using the heat, the molten phase, the molten phase, once it solidifies, it also invite many defects. Okay, so that becomes very challenging to develop these cladding and coatings for the very critical applications. So if any defect is there in these claddings, and there are several techniques which are there now to develop these cladding techniques for the hydrogen storage materials as well as the for the hydrogen transportation. Okay, so I'm just showing you some of the things, and then how. So these are the examples you can see here. These are the examples of the pipes, right? And they are used for basically these hydrogen transportation. And then, but the thing is, the techniques are many, but the thing is at the same time you have to make it economical as well as the energy efficient. And then what you have to do is you have to play at the interface so that no, when it comes into hydrogen contact, right, it should be it should be embrittlement resistant. Okay, so I'm giving you some examples where you can see um, we are contributing uh, our research in some of these directions where these materials are being used for the hydrogen transportation. So we are developing these pipes for the hydrogen transportation or hydrogen. Even the same material can be used for the hydrogen storage. Okay, uh, here. So you can see here we have developed these prototypes in the lab itself. So inside you can see. I hope you can see the slides, right? Dr. Binayak, you can see the slides.
Yeah, yeah.
Okay.
Absolutely clear.
Okay. So I hope you can see the slide. So what I mean to say here is we are developing these prototypes. So you can see the inside is the SS grade stainless steel material, which is cladded, and then outside you can see the aluminum. Okay. So in this way we are saving the weight. It is lightweight as well as it is serving the purpose when the hydrogen transports internally. Okay, it will not create the hydrogen bitumen problems. Okay, and the concept is very simple. We are using the casting process. Okay, the casting process, because when you make these pipes, the industry has to adopt this process. Okay, so it is industry accepted process. So generally the die casting is used for these pipes. Okay, these materials, and we have the same we have demonstrated into our lab, and then now these prototypes we have developed. So it is well accepted process, and then also the same time we are also fulfilling the requirement. Okay, of hydrogen transportation as well as hydrogen storage. So this is the concept I want to show you. We have the die and we have the molten metal, and then um, but here what we do is we put the stainless steel inserts. Okay, and this stainless steel of different grades we can use depending. Generally austenitic stainless steel is used for the to avoid the hydrogen embrittlement problems. Okay, so this is the concept here. So you can see here, I want to show you. um, it shows this. Okay, yeah. Okay, so this is the animation of the entire process which it goes here. Okay, so we get this cladding over the substrate here. Okay, so when we were doing the experiments in the lab, we have faced a lot of challenges during the process. um, but through our for understanding the entire work, and we have now eliminated all these defects and all these things. And so you can see here we have developed these claddings over these aluminum. Okay, and then you can see now, the I was telling you the interface, you have to play with the interface of these materials, right? So you can see the interface. This is the optical micrograph, where you can see one side SS304, another side you can see the aluminum alloy LM25, this is aluminum silicon alloy. And then you can see here we have developed the coatings, where you can see the four different layers. So these four different layers you can see here, they are basically different intermetallics. Okay, and so you will be knowing the intermetallics are brittle materials. Okay, so you have to also optimize the thickness of these intermetallics and their uniform thickness, as well as the diffusion. Okay, so and there is no defect. So I was telling you that you have to play the interface. So you can, this is the transmission electron microscope picture, micrograph, right? So my next topic is I'm going to discuss about these what we call testing for the different functional materials. So slowly now I'm entering into that. So the interface, you can see here, this is the transmission electron micrograph, where you can see the intermetallic layer, and then you have one grain, you have another grain, and at the nanometer scale. Okay, and then there is no defect at this nanometer scale. So this shows that the interface is defect free, and then it will serve the purpose for which it is manufactured, right? So you can see this is the bigger picture here. So we have published this work, and now we are making the prototype, and we are testing these materials on the hydrogen storage devices, as well as for the pipeline for the hydrogen transportation, along with the natural gas pipelines. Okay, so this is the device, and then we have developed the mechanisms, we have proposed these mechanisms, and then basically it is diffusion happening, but you have to control the entire process. Okay, okay, so we are developing these things. You can this is a better view. So you will ask question that, okay, you are making the pipe for these things, the applications. So, and then internal cladding is there, but you also need to ask question that this internal cladding should not have the any interfacial defect throughout the cross section, right? At one, maybe you can say that, okay, at one point it will have the better interface, another location it may not. So this picture is to show you we have done the testing where the entire cross section we have not observed any type of defect, and it is successfully cladded for these applications. Okay, so these are the things which I would like to just present you one application. So I have given you uh, the overview of the different energy systems, energy flow systems, and energy storage materials. And then I have given you one case study where we are developing the material for the hydrogen storage and hydrogen transportation device for pipelines, right? So I hope then now it is 8 o'clock. Uh, so we also have to start another topic, right, Dr. Binayak?
Yeah, Ajay. Next
Yeah.
week.
So slowly now I have entered into the part where now I can link the properties testing with the functional things. Okay. Okay. So if I take just 5 minutes break, then I can start that topic. Now I request, if anyone is having the question regarding this, they can feel free to ask.
Yeah, I request the participants if any questions are there with respect to your battery technology, materials that go into batteries, functionally gated materials that go into the battery, till covered till now, they can ask
Yeah,
on that.
because this topic is very vast. There are so many things to cover, and time is limited. So But if you have any question, or if you don't have any question later on, you can write to me, or you may write to Vinayak ji, or we can do that. We can do separate discussion as well. Okay, that also possible.
Yeah. So, Ajay ji, if you want 5 minutes break, you can take 5 minutes break, and then we can resume from where we had left.
Yeah. So now I will just take maybe 5 minutes break, and then I will come to the topic where um,
Characterization of all the
yeah.
FGM.
So I will start with the basics, and what you call, I will explain through the basics as well as the material aspect and the testing of the materials aspect. Okay. So, and in between you can ask questions as well. Okay. So feel free to ask question in between as well. Okay. So I'm available. Okay. Just give me 5 minutes. So I will, uh,
Yeah, Ajay ji. Yeah.
yeah.
Yes, yes.
Yeah, I don't have particular slides for this thing, so I will take some examples, and I will show you some examples and explain through that.
Yeah, yeah.
Yeah, and feel free to ask questions, please. Okay, be interactive.
Okay.
Sandeep has raised a question. Sandeep has raised the hand, I think.
Okay. Yeah, I'll unmute. I'll remove the restrictions, mute restrictions. Yeah, just a second.
If anybody is having messaging,
Yeah, the mute restriction has been removed. So if anyone is having questions, they can ask.
yeah, Mr. Sandeep, you are now, you can ask question. Anyway, they can keep question ready by the time I will come back. So that
Yeah,
you can say the timing.
yeah.
Yeah.
And you can also type the question in the chat box. We can
Yes,
take it.
yes, yes, yes.